In this video, we're going to be introducing polynomials. Then at the end, we'll also be adding and subtracting them. So we'll be starting with a polynomial, and then we will be rewriting it in standard form if it's not already. And then after we know if it's in standard form or not, we'll be classifying these polynomials by the degree and the number of terms. Now, there is a lot of vocabulary that we're going to cover during the video. And then after we've kind of gotten used to polynomials, then we'll look at identifying whether an expression is a polynomial or whether it's not. And then again, towards the end, we will be adding and subtracting polynomials. Here we have two polynomials, and we're going to rewrite them in standard form. Now, standard form, that's when you have the biggest exponent all the way on the left, and then as you go to the right, they get smaller, okay? So we're going to start out by looking over here to the polynomial on the left. We're looking for the biggest exponent. There it is, exponent of 5. So the 6x to the 5th goes first. Next up, we're looking for any 4s. Nope, no 4s. Oh, but we have a 3 here. So this minus x cubed, that will go next. And now we look for any 2s. Nope, no 2s. Here, this is an x term, x to the first, okay? So we don't write x to the first, it's just 8x, okay? So that'll go next. And last will be our constant term. So this is a minus 7 here, and that's going to go last. Now this does have kind of, I mean, you can think of it like as 7 and then x to the 0 power, okay? So we have a 5, a 3, a 1, and then a 0 there. I mean, if you want to think of it that way. Okay, now let's look at the one on the right. Looking for the biggest exponent, and right there, that's going to be a negative x to the 4th. So this minus does go with the x to the 4th. So when we rewrite this, make sure it's a negative x to the 4th there. So there's our x to the 4th. Now we're looking for an x to the 3rd, and we got one right there. And so that's going to be a plus, a positive 7x cubed. So there's a 3. Now we're looking for a 2. There's a 2. So that's going to be a 5x squared next. And now a plain old x term, x to the first term right there. 6x goes next, a plus 6x. And then the constant term, or the x to the 0 power term, would be there with a minus 9. Now that we have these in standard form, it makes it a little bit more easy to identify the degree and the leading coefficient of each polynomial. Now, these two pieces of information gives us the most amount of information about the behavior of the polynomial. So that's why they are important. So degree, that is your biggest exponent. So this one on the left there, the biggest exponent, that was a 5, right? On the variable, right? And now the one on the right, that's x to the 4th is the biggest exponent on the x. So the degree is a 4 for the polynomial on the right. Next up, we're looking at the leading coefficient. So coefficients, that's the number being multiplied to the variable. So in that case here, on the one on the left, that's going to be a 6, x to the 5th. So the 6 is the leading coefficient. And then on the right one, that's a negative x to the 4th. So we don't normally write negative 1 x to the 4th, but it is going to be a negative 1 for the leading coefficient. So now that we've talked about standard form, leading coefficient, and degree, we're going to keep kind of going through that, and we're going to be classifying polynomials by their degree and their number of terms. So the first one we're going to do is just 5. Okay, so 5, the degree, in this case, it is a 0. So we're looking at the exponent on the variable. Well, this one doesn't have any variables. It has 0 of them. So it's kind of a hidden 5x to the 0 power. So the degree is 0. Okay, next up, classify by degree. So with these ones here, you have some options. We haven't gone through these in this video yet. We're going to just, as we go, we'll be discussing them, all right? So options for classified by degree: constant, linear, quadratic, cubic, quartic. In this case here, it is a constant term. If it's just a regular number, that is called a constant, okay? Next up, classify by number of terms. In this case, there's only one term. So terms, the user-friendly definition is terms are things being added. So in this case here, you just have one, okay? So there's one term. So now our options are monomial, binomial, trinomial, and for anything bigger than trinomial, polynomial is just what we call it, okay? So in this case here, there's one term. It's called a monomial, okay? So other examples of monomials: 12x, 34x to the 5th, 67x to the 8th, y to the 9th, z. So those are monomials. Now, if you notice, there's no addition or subtraction. That's one term, that's monomial, okay? Next up, we have a 4x minus 3. Now, degree. Remember, degree is your largest exponent. Well, here you only have one factor of x here, so it is x to the first power, even though we never write to the first power. So degree 1. Now, degree 1, that's going to be linear, okay? So all degree 1s are linear. Now, if you remember back to when we were talking about like linear functions, y equals mx plus b, well, this polynomial follows that same format. We're talking about polynomials, they're still linear, okay? Next up, classify by number of terms. Remember, terms are things being added or subtracted. Here we have two terms. We have the 4x and a minus 3 or a negative 3 there. So that's two terms. So two terms, those are going to be binomials. Bi means two, nomial, two terms, okay? Last up, leading coefficient. This is the coefficient on your highest exponent variable, right? This one's going to be a 4. Here's 6x squared plus x. What is the degree? Degree is your highest exponent on the variable. In this case, it's a 2. So with all of your second degree polynomials, those are going to be considered quadratic, okay? So second degree goes with quadratic. Next up, classify by number of terms. Kind of like the last one, this one has two terms, two things being added or subtracted. We have a 6x squared and we have an x, so that has two terms. So anytime you have two terms, that is considered a binomial. Bi means two, and then terms binomial, okay? And then what is the leading coefficient? Remember, your leading coefficient is the coefficient of the variable with the biggest exponent. So in this case here, that's going to be a 6 there. So your leading coefficient is a 6. Remember, those leading coefficients are going to tell you a lot about how the graph behaves, how the polynomial behaves. Now we have x cubed minus 7x squared plus 1. What is the degree? The highest exponent is going to be a 3. Anytime you have a third degree polynomial, that is going to be considered cubic, okay? So third degree polynomials, that's cubic, okay? Next up, classify by number of terms. Terms, those are the things being added or subtracted. In this case, we have three of them. We have an x cubed, a negative 7x squared, and a 1. So there's the three terms there. Anytime we have three terms, that is considered a trinomial. Tri meaning three. Think tricycle, right? Has three wheels. Okay, leading coefficient, that's the coefficient on the variable with the biggest exponent. In this case, we have a 1x cubed. Okay, so 1x cubed, the leading coefficient is a 1. Now let's look at 5x to the fourth minus 6x cubed plus 7x squared minus 8. What is the degree of this? Degree, that's your highest exponent, so that's going to be a 4. Your fourth degree polynomials are called quartic polynomials. Now, we don't use that a bunch. It doesn't show up a bunch through Algebra 1 or 2. So this one's kind of a trivial, kind of a trivia thing. Quartic there, you can just call it a fourth degree polynomial if you don't remember the fancy name for it. Classify by number of terms. First off, how many terms are there? Well, in this case, there are 4 terms. 5x to the fourth, we have negative 6x cubed, we have a 7x squared, and we have a negative 8. 4 terms. Okay, so when there's 4 terms, anything more than 3, we just call it a polynomial, right? Poly means many terms. So if you have 4 or more terms, you can just call it a 4-term polynomial. Now, for leading coefficient, remember that's the coefficient from the highest exponent. So over here, highest exponent's a 4. There's a 5 right there. So 5 would be your leading coefficient. So now that we have done all of these examples one by one, we're going to look at the degrees of all of them at the same time to help our brains make that connection, right? So just the 5 there, that's a constant term or a constant polynomial. There's no variable, so the degree is 0 for none, okay? Next up, 4x minus 3, that's a degree 1, that's linear. That's an x to the first power, but we don't write to the first power, we just leave it as plain old x. Anytime you have exponent of 2 on your variable there, if that's the biggest one, that's called a quadratic polynomial. Next one, cubic, is for degree 3. And then for fourth degrees, they're called quartics. Now, anything bigger than that, just call it a 5th degree or 6th degree or 7th degree polynomial. And quartics, they don't come along very often. So if you forget that one, it's kind of a trivial one. It doesn't come up often enough to really make a big deal out of it, at least at this stage in algebra. Okay, sometimes degree is also called order. So the order of the polynomial would be like a 3 here or a 2 there or something like that. So just another word for the same thing. You might hear it from time to time. It doesn't come up that often in the United States, though. I think it's more of like a European thing. And then last thing, do make sure and get these in your notes. So that's kind of the summary of your degree, okay? So pause the video if you need and get those in your notes. Next up, we're going to look at number of terms. So letter A, that was just 5. That was one term called a monomial. There's other examples of monomials there for you as well. Next up, we have 2 terms. That's a 4x and a -3. 2 terms, that's considered a binomial. That does come up pretty often to know, okay? And then the last one that we have on here has 3 terms, so that's called a trinomial, okay? Now, if you have many terms, 4, 5, 6, 7, 8, we just call them just the generic polynomial. So again, pause the video if you need and get these in your notebook. Here's some definitions we didn't cover in the last 2 pages that you might also want to get in your notes, right? Standard form, that's where you have the biggest exponent all the way on the left, and then to the right, the exponents get smaller. Degree of the polynomial, that is the highest exponent, and then your leading coefficient is the number being multiplied to the variable that has the highest exponent, okay? So if it's in standard form, it's the very first number you see. So now that we've talked about different aspects of a polynomial, let's back up and talk about what a polynomial actually is. So the official definition of a polynomial is super confusing looking. It's a big algebra mess, okay? So you can kind of try and figure it out if you want. There's an example that kind of follows the same format. But honestly, really, this is what we need to know. So polynomials, right? They have only whole number exponents on the variables, right? You don't have any variables in the denominators, no division, and then there's no like square roots or cube roots on the variables, okay? So we're just going to practice identifying polynomials. So here we go. So this one here, we got 4x squared plus minus 9x plus 6. Yep, that's a polynomial, okay? Good to go. Letter B here. This one is not a polynomial. Check it out. We have a variable in the denominator or division by a variable. So letter B, not a polynomial. Let's look at letter C. Letter C is also not a polynomial. We're taking the square root of a variable. So that one's not a polynomial. All right, letter D. Right? Let's look at our exponents. Oh, we have whole number exponents only. So yeah, so letter D is good. And then letter E, oh, we have negative exponents on our variables. So that's not going to be a polynomial. Okay. So pretty simple as far as identifying polynomials. Whole number exponents on the polynomials only, no variables in the denominators, no square roots, cube roots of variables. Okay. So let's have you go ahead and try these ones out on your own. Pause the video, then come on back and see how you did. All right, so let's look at letter A here. Oh, we have a negative exponent on our variable, so nope, not a polynomial. Over here, letter B, oh, we got a variable in the denominator. Nope, not a polynomial. Look at letter C, their variables are only positive whole number exponents. So yeah, letter C is a polynomial. Letter D here. Oh, looks good, looks good. Nope. Oh, here we have a fractional exponent. Remember, we want whole numbers only for our exponents. So D is not a polynomial. Letter E, yep, that one's a polynomial. We have an exponent of 7, exponent of 4. We're good there. So now we're going to switch gears and do adding and or subtracting polynomials. With these ones, it's not super complicated. In your brain, just think add-like terms. So for letter A here, we have 6a squared plus 5a plus 4a squared. It's 3 monomials that we're adding up, but again, just think add-like terms. Generally speaking, I start with the highest exponent first. So let's look at the a squareds. How many a squareds do we have? Well, here we have 6a squareds and another 4a squareds that we're adding up. 6 plus 4 makes 10 a squareds. Now let's look at the a terms, okay? In this case here, we only have one term with an a, and it's a 5a. So boom, 5a goes there. Next up, letter B. Now this one's a little bit tricky because there's subtraction on it, okay? So we have 5b squared plus 11, and then minus 3b squared plus 7. Same strategy as before, start with the b squared terms, right? So here we have 5b squareds, and we're gonna minus 3b squared. So if you start with 5b squareds and you subtract 3b squareds, you're left with 2b squareds. Now there's no just regular b terms here, so now we move on to the constant terms. We have an 11 minus 7, so there's 11 and we're subtracting a positive 7. So 11 minus 7, that's just going to make a 4, and boom, done there. Let's have you go ahead and try C out on your own. Pause the video, then come on back and see how you did. All right, so here we go with 4c squared minus 2c plus 3c squared minus 9 plus 8c. So again, I recommend start with the highest exponent variable first, so that's going to be the c squared. So let's check it out. Here we have a 4c squared plus 3c squareds for a total of 7c squared. So we got 7c squared there. Now let's do the c terms. So c with no exponents. We have a negative 2c plus an positive 8c. So think of this as subtract 2c's from 8c's. So 8 minus 2, that's going to be 6c's there. Last up, we're going to look at our constant terms. No constant terms in this binomial. We have a constant term in this trinomial. It's just a minus 9. Now go ahead and try the next one out on your own. Pause the video, then come on back and see how you did. So here we go with 9x squared minus 3 minus 2x squared minus 8 plus 7. So again, start with the highest exponent first. In that case, this would be x squareds, okay? So we're looking at our x squareds. We have a 9x squared minus a 2x squared. That's going to make 7x squareds. Now let's look at the x terms. Now in this case here, we have no x terms in this binomial, but this trinomial does have an x term. But check it out. This is tricky. You're minusing a negative 8x. So anytime you minus a negative, you change that to a plus 8x in this case here. Now let's look at the constant terms. We have a negative 3 or a minus 3 minus a positive 7. So negative 3 minus 7, that's going to make a negative 10. Okay, now there is an alternative way of looking at these, and that's just rewrite it so it looks like letter A up there towards the top. Okay, so we just remember subtracting is adding the opposite. So our binomial is there, and then for this trinomial here, we're subtracting the whole thing. So that's a minus 2x squared. So you write minus 2x squared, and then you have a minus negative 8x. So that's a plus 8x. And then you can do minus a positive 7. That's just minus 7. And now you just do add like terms. And you'll still end up with the exact same answer as what we got here. Okay, so letter E, go ahead and try that one out on your own. Pause the video, then come on back and see how you did. So here we go. We're doing 5y squared plus 6y minus 9 minus y squared minus 2y plus 3. And now these ones are stacked vertically. So they look a little bit different, but it's basically the same idea. And you can do any of these stacked like this if you want to. But here we go. 5y squared minus a y squared, that's going to make 4y squareds, right? Now we have a 6y minus a negative 2y. So minus a negative is plus, so we're thinking in our brains, 6y's plus 2y's for a total of 8y's there. And then for the constant terms, we have a 9 minus a 3. So that minus there, kind of tricky. So 9 minus 3, right? So think you have to pay $9 and then you have to pay another $3. So you're going to have to pay a total of $12. So again, with these polynomials, knowing the degree, which is the highest exponent, the leading coefficient, that's going to give you the most information about the behavior of the polynomial. And again, that's going to be in standard form where you have the highest exponent first. And then we also went through figuring out what type of polynomial it is based on the number of terms and the highest exponent that's there. And then we also talked about adding and subtracting polynomials. Honestly, just think add like terms and you'll be good.